Hi everybody, it's Mrs. Maths Ireland here. Welcome back. So today we are doing my Leaving Cert hacks number 1, and it's all for the Leaving Cert higher level students today. But don't worry, if you're not a Leaving Cert higher level student, I have loads of hacks and videos on the way. So make sure you subscribe and you hit the notification bell so you know when the next one is uploaded, and I'm sure it'll be perfect for you. So let's go over to the screen and let me tell you all about this hack. So let's look at differentiation versus integration in today's hacks. So what I want to talk to you about here is the fact that when you go to differentiate a function, you do not really have to do any simplifying or tidying up before you can apply a rule. There's pretty much a rule for every scenario. Whereas if we go to integration, you do have to simplify and tidy up because you are limited with integration with the amount of rules that you have available. I will be going through examples as we go through this. So let's start with differentiation. If we have a look at our log tables, you can see we have this lovely grid here on the left hand side. We have a product rule, a quotient rule, and a chain rule. And there really is no situation where you won't have a rule to use. What you want here on the left hand side is for your scenario to match up identically with these scenarios, and if they don't, the product, quotient, and chain will be able to pick up the slack on that. And that is generally how you would go about differentiating. Now, I do want to point out there is one or two scenarios where you actually do need to do a bit of rearranging for the easiest route forward. And I'm going to show you that example now. For this question here, in an ideal world, I would actually use my rules of indices to simplify this before I differentiate it, just for the pace of it, just for to make it faster, to make it easier to use a simpler rule. However, in theory, you can use the quotient rule here if you really wanted to. But again, there's a lot of moving parts, there's a lot of labeling to happen, a lot of rearranging, and actually my way is much faster. So what we're going to do here is we're going to do our rules of indices. And what we're going to do is we're going to bring up that x to the power of minus 2, and it's going to turn into x to the power of positive 2. So we get 2x squared here. So now we can differentiate that using our lovely, simple, straightforward differentiation route. So it does make your life a little bit easier if you go down that route, but this really is the only simplifying that you need to do. And to be fair, you could get away without it if you really wanted to, but I do think this is a very simple simplification that will help. But in 99% of cases, you can go ahead straight in and differentiate with that rule in your log tables. So this here is a perfect example of why we would actually be using our chain rule and not the rule in the log tables. So if I jump back and show you the log tables, sine of x is what is in the table, and it has the instruction to get the derivative of it there. However, we have sine of 2x. That is not what's there, so you need to use your chain rule in order to find that. Okay, so let's look at integration in a little bit more depth. I said at the very start of the video that you do not need to tidy up for differentiation, but you absolutely have to for integration. And that is 100% true, because we actually have a limited amount of rules that we can use. It looks like there are a lot here, but as a Leaving Cert higher level student, you're not using these things here. So we're just using what's over here on the left hand side. So as you can see, we have a limited amount of rules. And if it doesn't fit in, you have to simplify it down, potentially using your rules of indices to make that happen. Okay, so let's look at an example. So here is one here that we're asked to integrate. So we have two things here being multiplied together. And if you have a look for this in your log tables, you simply will not find it here. So it's not there. So what are you going to do? You're going to rewrite it as something else. Now, you know that when you're integrating, you're always interested in the x's and the powers. So we know that x to the power of a half is exactly the same way as representing the square root of x. Now, before we move on, just be careful. Don't get it confused. When I'm trying to eliminate the square root of x, I square it. I square everything. That is because they are opposites and they cancel each other out. I'm not cancelling out here, I'm rewriting it as a power. So that's why we have that. And then we have this here. Again, you can see that there is two brackets being multiplied. Jump back here. There is nothing to show you how to multiply two brackets for integration. There is no product rule for integration. So you actually have to physically multiply these together. The best little tip I can give you here is actually put a power of 1 on that x and let's multiply them. So in order to actually multiply these together, we are going to use our rules of indices. And it's very important that you have them to hand when you're doing this, because to multiply x to the power of a half and x to the power of 1, it tells us to add them together. So we are going to have x to the power of 1.5 or 3 over 2 if you prefer. It doesn't really matter. And then minus 3 by x to the power of a half. I think I'll change that to 3 over 2 because that is more common in these types of questions. Now you have two x's with powers and you are going to integrate them now, because if we look at them separately, we'll integrate this bit and then we'll integrate that bit. So that has been Leaving Cert Hacks number 1. Come back for more. There's loads more on the way. I hope you enjoyed it. If you did, give it a big thumbs up, share it with your Leaving Cert friends, and don't forget to subscribe. I'll see you in the next one. Bye.